All right, I guess we got a fairly light crowd. Hopefully, hopefully we can entertain a little bit with OAuth, the spec, the dance, and how it might pertain to Drupal a little bit at the end. So that'll be setting up a site and kind of seeing how this all works. I'm hoping to actually provide a bit of education beyond OAuth, so actually how other authentication methods work in this, so you can see where OAuth's place actually lives kind of in the overall life cycle of developing authentication for your application, or maybe not, and just falling back on one of the other ones. So one place we have to start is, I'm Chris Christensen. I work at allplayers.com. We recently released OAuth 1.0 for our API, and so I learned quite a bit about both the client and the provider side on this, and you can reach me there. I have the Twitter handle if you're not familiar. So the place I want to start is actually pretty far back. We're probably all fairly complacent with the fact that we live on the internet and use HTTP 1.0, but I want to be very explicit about it. So we use these verbs, get, put, post, delete, head, in a client-server interaction. So this happens every day. When you go and you visit a website and you type, google.com, there's some magic that's happening in the background. And I'm hoping to familiarize with some tools to show what these interactions are, so that we don't have to think about them all the time. So in Chrome, there's a really easy way to see this. Firebug, all the tools like that. If you just jump over to the Network tab and actually load a page, I'm sure you may be familiar with something like this for performance reasons or to see what assets are loading on your web page. But we're going to focus actually just on the one web page load up here at the top, which is the actual page request itself. So this domain access requested a page, and the way it did that was by passing a get HTTP verb in the header. And then you can see here that the server responded with some response headers. And so in addition to the get, there was additional metadata passed back and forth. And you can see that subsequent to that, additional response items were HTML, so the actual content that was passed back. So this is the actual web page, and then from there, additional assets are loaded. So in this instance, there was no authentication. It was just a get, and we got flat HTML back. So pretty powerful. Another interaction, put, post. You might see a different verb here. So let's go to a different view of this same thing. If we viewed this on the command line, another way to do that is with curl. So we can actually do a curl command and request for google.com, and I'm actually going to go up here and put verbose so we can see what's going on. And this command will do effectively the same thing that the browser did, only we're going to see a lot more data. And if I scroll up to where I'm requested, what you'll actually see here is we have a fairly similar, actually identical, verb, and then a little bit different header data, and then same response. The server's responding, and you see there's some additional information here which we're actually going to get right into. So another website, I couldn't figure out how to do this with Google, so I'm going to jump over to DuckDuckGo, which is a Google competitor. So this one, if we do the same thing, they're saying it moved permanently. Yeah, so you can actually see here it's telling me to actually go without the www, so I'm just going to remove the www. And now I got some HTML back, and again, at the top, headers and response. But this time, instead of just requesting the front page, which actually if we just, for a sanity check, go to DuckDuckGo, just to prove that it's a search page, the only thing we're getting is that search box. So say we wanted to perform a search. We actually need to post to that form. So posting is a different verb than get, and we're going to go ahead and do that. So if I did this over here, you'll see that I just searched for hello, and they're actually showing a get over here, but on the command line we're actually going to do a post. So let me clear this out, go back to my command, and this time I'm going to provide a D, which stands for data, and that's automatically going to cause a post command, and we're just going to say query equals hello. And this is going to post, just to prove to you. We'll look at our headers, And we'll see here that the verb we used this time was post, and the header response, we got that and additional information. Now, if you look closely, and you can see how this was rendered, you'd see it is indeed returning the search page for that. So we've now used 2 HTTP verbs and seen the interaction. And another clever tool that I'll keep using here, I'll just demonstrate it now, is bcat, which is basically going to take my output that's coming from this command, and it's going to pipe it into an actual browser. And if I do that, what we should see here, hopefully, is the HTML rendered actually in the browser, and you'll see here, indeed, we're actually seeing the query from the page from hello. So great. We can use the internet on the command line. So let's go one step further. I need those basic skills. So one type of authentication you'll run across is basic auth. And this should be something everybody's seen where like a little pop-up flies down in your browser, and it says enter your username and password. And you can request this a variety of different ways. You can say in Apache, htaccess rules. You can actually basically what's going on here is there's a header that is being specified called www.authenticate, and it's requesting that you provide authentication. And then it's going to challenge you. So we should look at how it's going to challenge us. So I've got a snippet here, and this is just a web page that provides HTTP authentication, and so it's challenging us, and we're going to say, and the password I'm entering is 123, and it's going to give us an image back with 123. So what are the actions that's going on here? Well, clearly my username and password are having to be passed somehow, and the browser is building that information. So again, if we use our tools and we look at the network, this time I'm typing 1234. Let's look at our headers. So a little bit more this time. Again, it's a get, but this time down here in our request, we actually have an authorization header, and it says basic. Well, we're talking about basic HTTP authentication, so that's good. And look at this fancy set of strings and characters here. We have encryption. This is secure. I think not. This is actually just a base 64 encoding of the username and the password concatenated together. So to prove that to you, I'm actually just going to copy this. And again, remember I entered HTTP watch and 1234. We're just going to go over to our tools here and echo that string into base 64, and we're going to decode it. And you'll see there, indeed, it is just HTTP watch and 1234. So the point I'm trying to get across here is basic HTTP authentication is defined by a spec. The spec says use your username concatenated with password, base 64 encode it, and pass it up back to authentication, and that can be used as a defined way to authenticate to the web page. So some advantages to this, that's pretty simple. I mean, that's easy to implement, right? And again, we can do it a variety of different ways. But we don't want to be passing that over in clear text, so we better have an SSL connection. And is really, do we want to rely on the browser pop-up? Maybe there's another way we could do this. We could actually pass it another way. So let's look at how our frameworks do it. Our frameworks use something that is referred to as session authentication, or as the spec defines it, state management mechanism, which is your cookies. So you're going to have a basically state item stored on your local computer so that the remote server can know what to do. What does this look like? So this one is a little bit more involved to show. I've documented some commands here, but essentially what it's going to look like is I've got a test Drupal site here. If I go to it, you'll see here I'm just presented typical Drupal username and password box. So the username and password, I can type it in and then log in and post. And we've seen once before that we've used the HTTP post verb by passing additional data in. So what that might look like is a name, a password, and then this interesting part here is something that Drupal's helping us with, which is a form build ID, or rather let's see, is that the form build ID? Yeah, the form build ID, which is a token that's generated, which I'll explain why this is helpful in just a second, and the form ID, so we know which form we're posting to. So, again, cursor live demo. So let's see how this works. So I'm actually going to run this command, and I actually don't expect to log in right yet. And the reason is because of that form build ID. And so hopefully this comes up in an editor of sorts. Oop. So it's telling us something here. Let's see what it's telling us. Oh, it's actually telling us, so it is working. So the form token must still be valid. So let me actually remove. Let's just call this without posting to it so we can look at it both ways. So let's call this unauthenticated. Here we can actually see some form items. Being returned to us, and those form items we're familiar with. We're going to post an action to a user, and it's going to need a username and password. The exact same form items we see on the web page we noted previously. As a matter of fact, if I do that trick where I pass it to browser, that's exactly what we expect to see. So that's what we're seeing on the command line. Now, if I go back up and I run the command that passed the username, password, and the form token ID, which the form token ID is to hold us so that we can't replay the response, or more accurately, we couldn't just come to this form and post to it. We have to read it first. We have to have the token first before we can post, so that we're helping against bot traffic. I think that's a good way to explain that. And then it's telling us a redirect, and it's saying, you know, you're authenticated as this user. And now, if I use my cookie that was set here, so you can see that there's cookie information coming back, which was stored, if we look at that command, into the cookie jar, then you can see this is the file that it's holding. Somebody was calling it out there. Thinking. I'm actually just going to cat that to the browser. I'm actually logged in as the test user. So I've actually used the cookie to authenticate on the command line, back out. So now we've seen how we can have this piece of information that we can store locally on the computer, and that is exactly what we're using every day when we use a Drupal site. The browser is storing, and you can actually view this visually, so I'm going to do that visually now. If you look at resources and we log in as this user, you'll notice the cookies we're storing exactly the same way we're storing and managing on the command line. The browser is just doing it automatically for us. It conforms to the spec. And that's the key. Again, it's with basic HTTP authentication. Now let's think about this for a minute. Cache actually demonstrated several great techniques in terms of security vulnerabilities, but if we just look at the base level of what's going on here, it's a client-server interaction, and we passed a password over in clear text. So again, in this instance, SSL is important. It's actually even more important because this cookie is reused to confirm your identity with the website, and if you have that cookie, you're effectively that user. So again, everything should be going through an SSL tunnel, because that will help stop somebody from just grabbing that and looking in the middle at your credentials. However, there's another important point here as well. I'm actually now logged in as this user completely. So this concept, so if we look at this in the Drupal world, right, we can have roles to a specific user, but they don't exist in a authenticated, sort of authenticated, and then fully authenticated state. There is only a non-authenticated and authenticated state, and then we manage permissions on the application level. So wouldn't it be nice if we had a tool that allowed us to maybe request just the user's public information, but didn't give write access? Or if you had just a resource that was friends but not relatives. So that type of granular access control that you could hand to somebody else. The metaphor that you'll often hear with OAuth is the valet key for the web. So a concept where you can hand somebody this key to your resources, your car, and they can have limited access but not full access like you do, which is very different than your username and password on a site. Additional pieces to this are, you probably don't want to be handing your username and password to a third-party site. So if we think about Twitter and things we click on every day, we say, hey, yeah, I'll let you read my tweets, but I'm not going to hand you my Twitter password because maybe I use that password somewhere else, hopefully not my bank, but, but people have been known to do that. So those are the real power options. And just looking at the technical components, I think this is where we start to get hung up, which is, HTTP auth, that's kind of okay, it worked. I got a little involved here at the beginning. I wanted to demonstrate the complexity. Session auth, again, pretty easy because the browser's already handling it. And then we see this. And it's like this long query string. What's a nonce? I've never heard of a nonce before, although you have used it every day with something like a form ID, and a token. And really, what I want to try and abstract is that this is just a technique that's standardized. It's called signing. And the browser is doing it with sessions. The HTTP auth is doing it with that concatenating the string and doing a base 64 encode. And any good OAuth library will accomplish everything that you need to do for this signing methodology easily, just like the browser is already doing. So we've talked a little bit about what's special about OAuth. Yeah, there you go. So there's a couple of use case scenarios here. I give you access to my API, but read only. Mrs. Client is requesting access to your bank account. Would you like to allow that? So it's this concept of the valet key. And again, something else that I would like to be very, very pertinent is we talked at the beginning about HTTP. Client, server. That's all OAuth is. There's just stuff happening a little bit in the middle. Okay, so if anybody participates in the World Wide Web, we've probably heard of the rant by Aaron Hammer, and he is on the standards body, or used to be on the standards body for OAuth. He helped develop OAuth 1.0 and has been very influential in OAuth 2.0. So I would highly recommend reading. He has several blog posts on the subject. He quit the standards committee around OAuth 2.0, and the biggest takeaway I want to make, I want to address this in this talk because we don't need to throw the baby out with the bathwater. OAuth is extremely useful in many cases. We should continue to develop on it. His were directly directed at several items in just the OAuth 2.0 spec. So we're going to talk about OAuth 1.0 continuing today, but I don't think this should stop progress. So let's dance. So these are the interactions you should see on a day-to-day basis of what OAuth looks like. So Facebook's using OAuth 2.0, but the bottom two are Twitter and all players, and they're using OAuth 1.0, but the user experience is the same. It's a request of a third-party application that's saying, hey, can I act on behalf of you, the user, who's currently sitting at your desktop, to this service and do certain things? And then there's levels of certain things you can do. Read only, additional information. Facebook's very good about giving you high granularity access of, I want to give you my friends access or others and not others. But that's the user experience flow. And at a more general level, again, these are the same. These are actually taken from the same guy that Aaron Hammer. This is what it would look like. This is an example photo site and an example printing site. So the printing site's in green and the photo site's in orange. And the photo site's somewhere like Flickr where you upload your photos. So you're like, I have my family vacations. And let's just assume for a minute the World Wide Web can't see that. It's private. It's just where you collect your photos. But you want to print a couple. And to print a couple, you need to take those photos and give them to the printer. And maybe you don't actually want to give those to the printer for all time. You only want to give them to the printer for like 10 minutes so they can print them, and then they don't get to see any more photos. So the next 100 you upload, they don't have access to. So that's the scenario. So do you go to this printing site, and they say, hey, would you like to pull your photos from your photo site, Faji? And you say yes and do that. And the printing site requests a temporary token. So this is the dance scenario. And the temporary token is what's known as initiating the signing sequence. And that is where the client, which is the printing site, uses its credentials to say, hey, I'm about to ask a user if I can have access. And it takes those tokens and then redirects the user to their photos. And it says, hey user, something's happening, you need to log in, or you're already logged in which case the next screen shows up and it says, these temporary tokens that have been passed by the photo site are asking, hey, some printing wants to happen. Are you sure that's an action you would like to do? Approve or deny. So let's just assume for a second that you click approve, because if you click deny, everything just ends right now and nothing else happens. And you approve. When you approve, a redirection happens back to the printing site. And the printing site then takes the, gotta remember here, temporary token and the authorization token that came over and says, you know what? It doesn't know at this point if you've authorized her yet, but it assumes you have because it's been redirected, and says, give me the full access tokens. These are the tokens that are actually going to give me access to the user's photos. And then once it has those, it's just going to call the API like it would any other day, except this time it's authenticated and can pull down the photos and print them and save for like the next 10 minutes. Again, the key point, that's the dance. Every one of those steps was all using the same signing method. It was just different pieces of data going across. So some terminology that you might run across is, and I highly recommend the way to approach this if it seems confusing as you want to use this more and more, if you're not just using a module, is to actually go and read the spec, which is not as daunting as it sounds at all. But follow the terminology section, because sometimes things like client and server can be redefined to consumer, service provider, or a user could be a resource owner, right? These aren't complicated terms, they're just mappings. Additionally, this is the internet, so that dance is actually just nothing more than a series of URLs. And if we remember back, there was a temporary token request. That temporary token request was actually just a URL like request token. There was an authorize request, which the user was requested to press authorize. That was a web page that said /authorize. And then there was a, give me a full-on access token. Again, another web page that just says, give me an access token. So let's do some demos. First off, this is PHP. So this is actually going to start a little harder, actually, and then kind of progress to easier. So hopefully I grab you with the harder part. This is a fairly good testing tool. This just uses one of various of the OAuth PHP client app tools for signing. And in this case, all I'm doing is, remember in the dance, the first thing we do is request a temporary token. I'm requesting a temporary token with some credentials. And doing this, I've gone ahead and said, don't redirect, show me everything that's going to happen in the intermediary. It's gone to the request token page, and it's done a bunch of this stuff that we saw on that one page. And actually, the technical pieces that it actually did was it took the full URL parameter and ordered it in such a way, basically alphabetically, for all the pieces that it could discover, and then signed it using those pieces. And that is basically the key of OAuth right there, which is the ordering of URL query parameters and then signing them to do the request. And the reason you have to order them is because if we've ever seen a hash before, if you change any piece of the hash, it changes the result. So if we want the hash to agree on the client and server side, we need to agree on the order that things are going to be hashed in. So that's the hardest technical component. And the way that the keys look, consumer key, consumer secret, you're just going to get those from a web page like an app registration web page. So this is the all players consumer key registration, and this is the Twitter one. And I'm actually not doing a great job showing this. All you do is you register your app. You say, "Hey, I'm going to make an application that's requesting access on users. I need some credentials," and then it's going to give you those credentials. And these are your application credentials, your consumer key and your consumer secret. These are not the credentials that the user is granting. So those are granted to you after they've authorized. All right. So let's get to the easy part. Let's just look at Twitter. I've set up a Drupal 7 site with the Twitter module, and you'll see here that additional items come up in my registration block, and it says sign in with Twitter. I'm just going to click it. And oh, wow, so Twitter's kind of cool. I had already clicked allow on Twitter earlier, so it just passed me right through and created my account. So all three of the dance steps that we just previously discussed happened right there. So let me show you a different view of that. This one I haven't granted it access, so I'm going to click login. Like we saw before, there's a grant access step. So behind the scenes, what's already happened is a request for a token has happened and a redirect has happened for the user. I'm now the user. I'm clicking authorize, and now the app is going to request. Awesome. Yeah. Let's try that again. Now the app is going to redirect and actually both confirm the tokens that I have and then request them information, and then once that's done, Drupal is doing a user load and then logging me in. And so you can see here I'm this user that has administration rights. All right, so now one step further. I didn't know if I'd have time for this, so as I do this, I'm hoping to install a Drupal install and replicate that Twitter example from start and answer questions. Yes, Travis?
You can do this installing while I'm asking my question. So what if whoever you're trying to authenticate with does not provide what Drupal requires for their user?
Great question. So you actually just saw that in the Twitter example. So Twitter does not provide, I'm not actually sure of the cases, but it doesn't normally provide an email address. So Drupal actually does require an email address by default. So the Twitter module is actually doing some special work to bypass that. So let me jump back to that example. You'll see here it says you've been automatically registered with a password and logged in. If I click my account settings, even though I logged in with, it gave me a username somewhere. Yeah, so it gave me a username of my Twitter handle that I logged in with. But you'll see I don't have an email address. So it didn't have additional provided information. This is left up to the implementer. So in the Twitter example, the module is making a brief assumption that, okay, well, maybe you don't require an email address, so we're just going to go ahead and let the Drupal site behave like that. If that's something you didn't desire, then you would need to halt there and say, before I continue your registration on this Drupal site, go ahead and provide an email address. And you'd have the Twitter credentials in that session before you continue through. So it's kind of like a second step to the overall process.
Does the Twitter module bake that in for you so that you can set up, or does you have to build that?
The Twitter module does not, as far as I know. Patch is welcome. It's not my module, though, so whoever's that is. Mad props. Yeah, they'd love that. For the All Players module, actually, I can promote that a little bit and say that if I log out, I'm going to log in as a different user. So this is again, it's asking for some access. The reason I'm logging in as this user is I know they have a first and last name, and this module supports mapping profile fields. So the mapping of the profile fields actually fills out. It not only queries for the email address of the user to fill in the Drupal registration, but it also fills in the profile fields. And this is the Facebook module does a nice job on this as well. OAuth, thanks Lullabot for that one. And again, and that one's actually a little bit simpler because Facebook uses bearer tokens. Let's see here. Did I answer your question, Travis?
Yeah.
Okay. All right. We got a demo site. Hopefully we don't need a... All right. So let's go register our Twitter app. This is the other site, so I'm just going to close that out. Hopefully Twitter doesn't care if I register more than one app, so we're doing it live. So here's the website, and the callback URL is curious what's going on here. So we don't know the callback URL yet. The way we're going to discover that is by actually installing the Twitter module. Dead air. Awesome. Oh, did it not submit? Apparently not. Should have used Pantheon. Alright, so apparently I'm not going to demo it live, but you can install the Twitter module, and what it'll give you is a callback URL to call, which will be specific to that site, and then you'll also enter those credentials that ultimately, when you register the app, show up over here, and those allow you to basically begin the signing process. Yeah, you can act on behalf of my app if you copy those down. It is. It's very similar. So basically what you're going to end up doing is you're going to take the consumer key and the consumer secret, and that's going to be provided on your server. And when you begin the signing process, you're going to take the URL, and you're actually only going to provide, if you can see in this, and I know there's a lot of text on the screen, but the key I want to get across is there's only the key presented, the secret's kept inside, and you don't want to share the secret. So the way that that shared secret is passed is you sign the URL, and the way we have to sign the URL is, again, ordering the items in a specific way so we can agree on both sides what it's supposed to look like, and then that's able to be unsigned on the other side. And the trick, so again, that's the signing process, that's the mechanical piece. The trick with OAuth is the dance. So it's first requesting the temporary token, requesting the authorization, then requesting the permanent token that you can actually request on behalf of that user, and that's a different key. It's actually per individual. Man, it's not right. All right, let's try this again. All right. Well, should have set it up locally or something. The difference, one thing to note is the reason I was going for a public URL, public IP, is because Twitter does require that it be a publicly accessible one. That's their requirements. Not all apps require that, so there's varying levels. And that's actually left up to, it's ambiguous in the spec. And that's something kind of important about the spec is it leaves some items where it says kind of, make this more secure at your, or more rigorous maybe is a better example, at your leisure. So Twitter's choosing one part of that. Facebook's a great example of the scope argument. So Twitter, if you've ever authenticated with Twitter, it says allow like just read or write, whereas Facebook's like read my email, write my email, read my friends, write my friends, read my that. So they took and went one extra step. So that's kind of an example of the different granularities you can put. So we use it with, it's actually just wide open, so it's auth on or off. So we intend to go down the path. This is our API documentation site, which looks awesome on the screen. So these are all the resources we provide, the access. So we intend to have the scopes per resource, or per grouping of resources. So really it's around users and groups. And maybe to make that a little bit more clear about what we do, we manage and organize youth league and league recreation sports, and really what that comes down to is like a set of users and a set of groups. So we use OG heavily, and basically our scopes will live on top of that kind of concept, which is, you know, like have access to your group mates, have access to your events, write the events that are on that group type of level.
You use that inside your site, or you were saying that you were setting this up so that as a web developer, I can write my site to access your.
It's much more themed. We actually use for our inner site communication. We're mostly Drupal. For that, we use Bakery because we can agree behind the scenes. Well, first of all, we're on the same domain, and then behind the scenes, we can agree on a server sharing a secret. This is for likely a different domain and likely a third party. So in this instance, you can use the all players Drupal module, take a Drupal site, and I had it up here actually. Yeah, this is the Drupal 6 site example, and register users with their already registered account on all players, or for kind of like a single sign-on type experience. And we also have like a WordPress implementation, so it provides that flexibility. And that's actually all, just to be totally transparent, all of that was implemented with the OAuth and OAuth kind of community of modules on Drupal.org, so we're the provider with those modules. And you can see all those patches in the issue queue. And we're looking forward to OAuth 2.0. Okay. Okay, thank you guys.